Good afternoon, class. We are looking at Chapter 6, Periodic and Trigonometric Functions, 6.31, Inverse Trigonometric Functions, Part 1. So we've looked at graphs of sine and cosine, other trigonometric functions, phase shift, sinusoidal curve fitting, and now the inverse function, so the inverse sine, cosine, and so on. So the objectives are find the exact value of an inverse sine, cosine, or tangent function. Find an approximate value of an inverse sine function. Use properties of inverse functions to find the exact values of certain composite functions. Find the inverse function of a trig function. Solve equation involving inverse trigonometric functions. So that's the topic that we are going to cover as far as this section is concerned. So what have we covered so far? Properties of trigonometric functions, fundamental identities. Everybody should be comfortable with the following. This is a unit circle, x squared plus y squared equals 1. A pair has coordinates x comma y, x or cosine t, y or sine t. And if that is the case, tangent is y over x because it's sine over cosine. Cotangent is x over y because cosine, it's cosine over sine, and the rest of it follow. Also, if we look at x squared plus y squared equals r squared, then a point with coordinates x comma y or a over b results in sine theta, this time to be y over r or b over r. Periodic functions, they repeat, okay, the value at regular intervals. For example, all trigonometric functions are periodic with the period of 2 pi except tangent and therefore cotangent, which is pi. All trigonometric functions are odd functions. That means f of minus x is minus f of x. But cosine and therefore secant are even functions, which makes f of minus x equals f of x. Fundamental identities. A Pythagorean theorem, sine squared and cosine squared, they add up to 1. Tan squared plus 1 is secant squared. 1 plus cotangent squared is cosecant squared. Quotient identities, tangent is sine over cosine, cotangent is cosine over sine. Reciprocal identities, cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent. And what is important for everybody to know is that if cosecant is 1 over sine, therefore sine is 1 over cosecant. As I mentioned, the even and odd functions, all of them are odd except cosine and therefore secant functions. Graphs of sine and cosine, we cut them into a complete period of 0 to 2 pi. We cut it into 4 equal parts. And therefore, we create 4 arcs from 0 to pi over 2 pi over 2 to pi, and so on, both for sine and cosine. So 1, 2, 3, 4, 1, 2, 3, 4 arcs. Also, sine x is cosine of x minus pi over 2. Finally, in the case of sine and cosine, the period is 2 pi, amplitude is 1. In the case of y equals a sine omega x or y equals a cosine omega x, period t is 2 pi over omega, and amplitude is the absolute value of a. As far as the phase shift is concerned, to graph sinusoidal functions of the form, we've already explained what to do, but in this case, there is a phase shift. You do as follows. If you have a general case like this, first you take the omega out. The same thing for sine or cosine. Amplitude is absolute value of a. Period is t equals 2 pi over omega. The phase shift would be phi over omega. If phi is less than 0, ps, short for phase shift, is to the left, and phi is positive, ps is to the right. And in many texts, instead of those variables, they write y equals a sine of bx minus c plus d. And remember, b has to come out and becomes the coefficient of the parentheses to give you the phase shift. So that's the synopsis of what we've covered. And now the inverse function. 6.3, the inverse sine, cosine, and tangent function. Review of properties of functions and their inverses. Only one-to-one functions have inverse functions. Therefore, reminding you that f of inverse of x means x, and this x is in the domain of this second piece, the inner function, which is f inverse, and f inverse of f of x is also equals x, but this x is in the domain of this function. The inner function in this case is f of x. In this case was f inverse. The domain of f of x is the range of f inverse of x, and the range of f of x is the domain of f inverse of x. In other words, domain and range are interchanging because x and y are being interchanged. And the graphs of f of x and f inverse of x are symmetric about the line y equals x when graphed on the same axis. Composition of inverse function is such that f of f inverse equals f inverse of f equals x, both of them. And that's very important to pay attention to, everybody. So we want to come up with the inverse sine function, sine inverse of x. And I remind you that every trigonometric function is periodic. And therefore, it fails horizontal line test. So y equals sine x. The domain is from negative to positive infinity. The range is from -1 to 1. It's not a one-to-one function, and it does not have an inverse. However, we can restrict the function just in the blue part, becomes a one-to-one, and now it has an inverse. So only the blue part, y equals sine x, domain x is between negative and positive pi over 2. It includes the endpoints, range -1 to 1, and this is a one-to-one function, everybody. And now we can have the inverse. So the restriction is important. Everybody should remember the restriction. Y equals sine inverse of x means x equals sine y. That's by the definition of inverse functions. Domain becomes, range becomes the domain from -1 less than or equal to x is between -1 and 1 inclusively. Domain becomes a range here. And so let's look at the pairs. Negative pi over 2 minus 1 becomes -1 pi over 2. 0, 0 remains as 0, 0 because when you interchange 0, 0, that doesn't change. Pi over 2, 1 becomes 1 pi over 2. So you look at the three easy points and then interchange x and y, and you graph it, and it looks like this. And that is the red one. The blue one is the sine inverse. Y equals sine inverse of x. That's as far as the graph is concerned. Now, let's take a look at a couple of simple examples to understand the concept better. Find the exact value of the inverse function. Warm-up example, sine inverse of 1 is equal to theta. That means sine inverse of 1 is missing. That means we set it equal to theta, alpha, beta, gamma, x. You choose, for example, theta. Okay. And by definition of the inverse function, what does that mean? That means sine theta must be 1. That's the meaning of it. And of course, again, just to remind you of the graph, you should know sine theta equals 1 is a common arc. Theta is pi over 2 or 90 degrees. And that's it. Because of the restriction that we put on the sine, this portion of it is of interest to us, and this portion, of course, is 1, 2 pi. Okay. Now, sine inverse of 1/2. What is it equal? What is it equal to? You set this equal to any variable of your choice, for example, theta. And then by the definition of inverse function, this means sine theta must be 1/2. This is a common arc. We know the answer to be pi over 6. And it's extremely important to know in a complete revolution, sine theta equals 1/2 has two answers. But the restriction here, okay, minus pi over 2 to pi over 2, that means fourth and first quadrant. And in the first quadrant, sine is positive. That's why the inverse function has only one, as a unique solution. What about negative 1/2? Well, sine inverse of negative 1/2 equals theta, alpha, beta, gamma. Your choice. Therefore, sine of theta must be negative 1/2. And again, we should know the restriction that we put here. Theta is between negative pi over 2 and pi over 2. And this means the answer is, if it were positive, pi over 6. Because it's negative pi over 6. Again, we are looking at common arcs. That is pretty straightforward, everybody. The inverse sine, cosine, and tangent functions. Find an approximate value of an inverse sine function. Answer in radians with 4 decimals, sine inverse of 1/3. The reason they're asking for the approximation, they are not common arcs. And ultimately, we don't know the answer. We have to use a calculator. So sine inverse of 1/3, you can say it's equal to theta. That means sine theta equals 1/3. And of course, you have to use a calculator. It doesn't help. So just put this in a calculator and it will give you the answer. Sine inverse of 1/3 is this. And we want 4 decimals, 1, 2, 3, 4. 8. Next to it is 3. It doesn't change. 0.3398. So you have to use a calculator on that. There's really not much we can do. What about this one? The same thing. You can say that, let's say even equals x, means sine x equals negative 1/4, not a common arc. So you just put it in the calculator, sine inverse of whatever this number is, and it gives you negative 0.25268 and so forth. And we want 4 decimals. So 1, 2, 3, 4. Number 6, next to it is 8, goes up to 7. So negative 0.2527. And by the way, they want it in radians. You have to put it in radian mode. By the way, if you have any doubts and you don't know how to change the mode, always put something that you know. For example, if you put sine inverse of 1/2, okay, and it gives you 30 degrees, that means it's in degrees, or it gives you pi over 6. So you have an idea how to deal with that. All right, so we are going to go with the composite function, FO F inverse of x, and reminding everyone that F inverse of f of x is f is equal to x, f of f inverse equal to x. In this case, so if we look at sine inverse of sine x, this x belongs to sine, and it has to be between these two numbers, minus pi over 2 to pi over 2. Pay attention to the inner function. In this case, the inner function is x. Whereas here, the inner function is the sine inverse, which is really the range of sine, which is -1 to 1. Now, this is sine inverse. Because this 0.5 is in between, then the answer is x. That means 0.5. So f of f inverse of x is x because this number is in the proper range, and the answer is 0.5. And even if you put it into a calculator, it will give you the same answer. Sine of sine inverse of 0.5, it will give you the same answer. Now, what about sine of sine inverse of 1.8? Look at the inner function, sine inverse. Sine inverse must be between -1 and 1. It's not, it's undefined. It doesn't have any solution. And even if you put it into a calculator, it doesn't work. One way to find out, okay, pretty much you get to the answer because sine is between -1 and 1. One way to do this is to look at this part only and say, okay, sine inverse of 0.8 equals x. That means sine x must be -1.8, and this doesn't work because sine is between -1 and. So that's something you want to be careful of. So when you go with the composite function, take a look at the inner function and the domain of that function. All right, let's move on. Find the exact value of the following composite functions. Sine inverse of sine of power 8. And again, reminding everybody that sine inverse of sine x, you look at, gives you x. This is the inner function, must x be between these two numbers. But in this case, sine inverse is the inner function, and x must be between those two numbers. Having said that, sine is pi over 8 between these two numbers. If it is, then the answer is itself. Yes. Pi over 8 is an element of, this is read an element of, let me write this. This is read an element of. That means it's in between. Because this is in between, the answer is pi over 8. And we're done. Let's look at this case, and we are going to look at the same thing. Is 5 pi over 8 in this interval? As you know, pi over 2 is the same as 4 pi over 8. Pi over 2 is the same as 4 pi over 8. This is larger, and therefore it's not. See, we use the same thing. We cross it. 5 pi over 8 is not an element of this domain of negative pi over 2 to pi over 2, okay? Which is the domain for the sine. So what do? We find an angle in this interval for which sine theta and sine of 5 pi over 8 are the same. And reminding everybody that sine is positive in the first and second quadrant. So take a look. Sine corresponds to the y coordinate. In the first and second coordinate, y is positive. And so sine of theta is equal to 3 pi over 8. 3 pi over 8 acts as a reference arc. This is 5 pi over 8. For 5 pi over 8, the reference arc is 3 pi over 8. So they have the same value. They have the same y value. So it's the same as sine of 3 pi over 8. Okay, you can look at it this way, however you want to look at it. But it's important to understand the situation with sine. It's positive in the first and second quadrant. Therefore, sine inverse of sine of 5 pi over 8 is the same as sine inverse of sine of 3 pi over 8. Therefore, the answer is 3 pi over 8. So this must be in the proper domain. If it's not, see this one is in proper domain, no problem. This one is not, you have to work with that. And that's what happens. So be careful when you are working on the inverse functions, trigonometric functions. All right, let's look at cosine. Here's the cosine function. Y equals cosine x. X is between negative and positive infinity. Y is between negative 1 and 1. And it's not a one-to-one function. None of the trigonometric functions, because they are periodic, none of them passes the horizontal line test, and none of them is one-to-one. But we can restrict it to this portion, the blue portion. Now, one might say, why are we restricting it differently? Remember, you want to restrict the function in a manner that covers all the range, okay? So for example, if I do the same thing as sine from minus power to power 2, I can't cover the negative side. It's from 0 to 1. So from 0 to pi covers everything. And so this is the portion, of course, we have zoomed so we can clearly see 0, 1, power to 0, pi minus 1. This portion now has an inverse because it's a one-to-one function. So y equals cosine x. Domain goes from 0 to pi. X is between 0 and pi. Range goes from between negative 1 and 1. And again, exclusively, that means the endpoints are included. This is a one-to-one function. This has an inverse. So we are going to write y equals cosine inverse x. X is cosine y. Domain, you put the range here between negative 1 and 1 for cosine inverse. And domain of 0 to pi for cosine becomes range of 0 to pi for y. And so let's look at those 3 points that I mentioned. 0, 1, pi over 2, 0, pi negative 1. Just becomes 1, 0. 0 pi over 2, pi negative 1. So 0, 1 becomes 1, 0. Pi over 2, 0. 0 pi over 2. Pi minus 1 becomes negative 1 pi. Look at this one, this graph. And if you, of course, graph both of them on the same set of axes, must be symmetric with respect to the line y equals x, because that's the nature of inverse functions. Find the exact value of an inverse cosine function, cosine inverse of 0, and again, reminding you of that. So let it be alpha, beta, gamma you choose, for example, theta. That means by definition of an inverse function, cosine theta must be 0. Again, I hope by now everybody has memorized the functional value for trigonometric functions that are common arcs. Cosine theta is 0 when theta is pi over 2, and it's a unique answer, one solution and one solution only, pi over 2. Same thing here. What is cosine inverse of 1/2? Let it be equal to any variable of your choice. For example, theta again. Therefore, cosine theta must be 1/2. That is also a common arc. Cosine theta is 1/2. Theta must be pi over 3. So we should be familiar with those. Cosine inverse of negative 1/2, again set it equal to theta, and by definition of an inverse function, cosine theta must be negative 1/2. And remember, the domain of cosine that we have restricted is from 0 to pi, and it is positive in the first, negative in the second quadrant. So just to remind you, if it were positive 1/2 would be pi over 3. For negative 1/2, you say pi minus pi over 3, which becomes 2 pi over 3, okay? Because this acts as the reference arc for it, for positive, okay? That's how you figure it out. The last one also set it equal to theta. By definition, therefore, cosine of theta must be this number, negative square root of 2 over 2. And again, just to make sure we understand that, if you go with square root of 2 over 2, it's pi over 4. Remember that cosine of theta equals square root of 2 over 2 is pi over 4. We should know that. So this is the same thing, pi minus pi over 4. So let me write that first for you. So as cosine theta equals square root of 2 over 2, theta equals pi over 4. Okay. So for this, theta, this acts like a reference arc. For this becomes pi minus pi over 4, which is 3 pi over 4. Okay. Again, just the way you get to negatives, arcs. We want to find the exact value of the following composite functions: cosine inverse of cosine of 5 pi over 6, and we have the inverse functions written here, so that shouldn't be any problem. Again, it's important to pay attention to what? To the inner function. The inner function gives us the x that we are interested in. If it's in the proper domain, they undo each other, and the answer is x. The answer is 5 pi over 6. And is it? Well, in the case of a cosine, we have to restrict the x between 0 and pi. Is this between 0 and pi? Yes. So the answer is 5 pi over 6. And that's the idea. Can we restrict it? Can we see the restriction? Yes, and it works. Let's do this one. Okay, so cosine inverse. Now, for cosine inverse, this is the x coordinate of cosine inverse. And for that, we come here. This number, is it between -1 and 1? Yes, it works. So the answer is 0.2. 0.2, since 0.2 is in the interval of -1 to 1. So pay attention to the inner function, everybody. Pay attention to the inner function. Now, cosine inverse of cosine of 5 pi over 4, the inner function is cosine, and this must be between 0 and pi. Is it? No, because 4 pi over 4 is pi. Therefore, this one is larger than that. It's not. In fact, this is in the third quadrant. So, what you have to figure out, cosine of 5 pi over 4. Now, think about the reference arc. So it's the same as cosine of pi over 4, but in the third quadrant is negative, okay? So between 0 and pi, in the second quadrant, cosine is also negative. So therefore, it works like 3 pi over 4. So 5 pi over 4 is not in the interval of 0 to pi. Find an angle with the same cosine value, and that would be Cosine of 5 power 4 is the same as cosine of 3 power 4. Reference arc is power 4. For power 4, we get positive 1. For these two, for power 4, we get square root of 2 over 2. For these two, we get negative square root of 2 over 2. And therefore, this is the same as cosine of 3 power 4, and the answer will become 3 power 4. You can even replace this with the value of negative square root of 2 over 2 and work it out that way. Okay. If you go that route, and that's fine, you can say this, and this is equal to theta cosine theta equals minus square root of 2 over 2, and therefore theta must be that, if that works. That. Now, the last one, there is no solution. It's undefined. And because this belongs to the inverse, must be between -1 and 1, but 2 is not between -1 and 1. And therefore, it has no solutions. It's undefined. Okay. Now, what about tangent function y equals tan? We are looking for y equals tan inverse. So first we look at tangent. And again, that's not a one-to-one function. Y equals tan x. Domain is all real numbers. X can be 2n plus 1 power 2. All real numbers except those, because remember, tan is sine over cosine, wherever cosine is 0. Let me write that. So you don't have to memorize it. Just remember. I'm assuming everybody remembers that this is sine over cosine. So wherever cosine is 0, you get vertical asymptotes. That's the idea. So, and of course, for the domain, all real numbers except those, not a one-to-one function. So the restriction, because we want to cover all the domain, we go right with one complete cycle from negative power 2 to power 2. Now this one is a one-to-one function. So y equals tan x domain from negative power 2 to power 2, range negative infinity to positive infinity, one-to-one function. Here's what I want you to notice. This function, the same as sine, goes between negative power 2 to power 2. However, the endpoints are not included. And that's the idea I want you to pay attention to. That is the main difference. The endpoints are not included. Okay. So having said that, we are going to write the inverse. Y equals tan inverse of x means x equals tan y. Domain is negative infinity to positive infinity, because remember, the range here is negative to positive infinity, becomes the domain for the inverse. And the domain becomes the range minus power 2 to power 2. And so let's write a few interesting facts. Okay, everybody knows negative power 4, -1, power 4, 1, 0, 0. So we know those 3 points. The vertical asymptotes, x equals minus power 2, x equals power 2. We are just writing 2 of them because that's the restriction. So for this one, the point is -1 comma negative power 4. For this one, the same. For this one is 1 comma power 4. If the vertical asymptote has the equation x equals minus power 2, for its inverse horizontal asymptote has the equation y equals negative power 2. And the same thing here, x equals power 2 refers to horizontal asymptote of y equals power 2. And if you graph them, and on the same set of axes, they both go through 0, 0, and they cross the y equals x, and the two functions cross each other at the origin. So y equals tan x has two vertical asymptotes. Y equals tan inverse has two horizontal asymptotes. That's a very important piece of information that we need for later courses. So a quick recap. Tangent functions, like any other trigonometric functions, they are not one-to-one. Restriction into just a complete cycle makes them one-to-one. And for that, we can come up with the tan inverse. And to come up with the tan inverse, domain becomes range, range becomes domain, and the pairs change, interchange, vertical asymptotes become horizontal asymptotes. So we want to find the exact value of the inverse tangent function. Tan inverse of 1 is of interest to us. We'll let that be equal to any variable, for example, theta. If so, by definition of an inverse function, a tan of theta must be 1. And that is a common arc. So theta becomes pi/4. Tan inverse of negative square root of 3. Same thing. We set it equal to theta. By definition of an inverse function, tan of theta must be negative square root of 3. And tangent, just like sine, covers the fourth and first quadrant. Square root of 3, we know it to be pi/3. So for negative square root of 3, theta must be negative pi/3, a common arc. Over here, we set equal to theta again. By definition of an inverse function, tan of theta must be square root of 3/3, which is a common arc. Theta must be pi/6 or 30 degrees. It's just normally we report it in radians unless otherwise asked. What happens here? The same thing. You set it equal to theta, and by definition of an inverse function, tan of theta must be negative square root of 3/3. And again, remember tan theta, as I mentioned, for the inverse, we have the fourth and the first quadrant. And since square root of 3/3 gives us pi/6, negative square root of 3/3 must give us negative pi/6. So pretty straightforward. So a quick recap. You want to find inverse trigonometric functions, and you are given, for example, tan inverse of some number, set it equal to some variable such as theta, and then by definition, change it so that tan theta equals 1, common arc, find it. If it's not a common arc, you may have to use a calculator, or it may be undefined. All right, we want to solve equations involving inverse trig functions. 2 cosine inverse of x is pi/2. So obviously, we're going to divide both sides by 2. And that means cosine inverse equals pi over 4. By definition of an inverse function, cosine of pi over 4 must be x, or x must be cosine of pi over 4, a common arc. You know it to be square root of 2 over 2. So x equals square root of 2 over 2. Let me just erase my work. Part B, 3 sine inverse of x equals pi over 2. And the very first thing we do, divide by 3. So the left side becomes sine inverse. The right side, pi over 2 divided by 3 is pi over 6. So by definition of an inverse function, sine of pi over x, pi over 6 must be x, and that's a common arc. We know the sine to be 1/2. That's pretty straightforward. Now we have 5 sine inverse of x minus 2 pi equals 2 sine inverse of x minus 3 pi, which means we have to move things around, everybody. That's all. Such that we can collect like terms, just like any uh, algebraic expression. So what does it mean? We are going to move negative 2 pi this way becomes positive 2 pi, and move 2 sine inverse of x this way becomes negative 2 sine inverse of x. So now you have 3 sine inverse of x on the left side, negative pi on the right side. Again, that's pretty straightforward, everybody. And the rest becomes very straightforward, very simple. Divide by 3. Sine inverse of x negative pi over 3 by definition means that sine inverse of x equals negative pi over 3 means sine of negative pi over 3 is x. And of course, everybody knows this is minus sine of pi over 3, which is square root of 3 over 2. So minus square root of 3 over 2. Pretty straightforward, I hope. Example 8, find the inverse trigonometric function domain, range, and etc. Find the inverse function f inverse of f of x equals 2 sine x minus 1. Find the range of f and domain and range of f inverse. And in this case, they are giving us for this one, the domain x is between negative and positive power 2. So what is the process? Let's start with if we want to find the inverse. Let's start with f of x, and to make life easy, we change the f of x to y because that makes it easier to deal with. How do you find the inverse? Interchange x and y. So this becomes x, this becomes y. So step one, f of x, call it y because it's easier to deal with. Step two, y becomes x, x becomes y. Right here, we have the inverse function. However, we solve for y. So to solve for y, move this to the other side and then divide by 2. So you get x plus 1 divided by 2. So by definition of an inverse, if sine y is x plus 1 over 2, we can write sine inverse of the left side. Sine inverse of x plus 1 over 2 is y. Again, by this definition. And practically we're done. Y, or f inverse, is sine inverse of x plus 1 over 2. We are done for the first part. We found the inverse function. Now we want to find the range and the domain. Well, let's go back here. This is the domain of the function f of x, which becomes the range of the function f inverse. So domain is given as what you see here. Then range of f inverse, that means y between those two numbers, is the same thing. Recall that the domain of f is the range of f inverse, and the range of f is the domain of f inverse. Therefore, range of f inverse is the same thing. Y is between negative power 2 and power 2. Now, to find the range for this function, which becomes the domain for this function, let's work on him. I'll show you a couple of different ways. So I can find the domain of this function because I know the domain for the sine inverse is between negative 1 and 1. So the domain must be between, well, imagine this is theta, okay? Theta must be between negative 1 and 1. Alpha, gamma, x, y, z. So whatever this expression is. So x plus 1 over 2 must be between negative 1 and 1 because of this, everybody. So solve for x. How do you solve for x? Let's multiply everything by 2. This becomes negative 2. This becomes positive 2. The denominator goes away. Positive 1 subtracted from all sides, meaning minus 1, minus 1, minus 1. And that's the end of the story. This is the domain for f inverse. So the range for f, y is between the same numbers. This is the domain of f inverse, which makes it, so domain of f inverse is this, which makes it range of f. We are done, class. But I want to show you a second method, just for practice, because sometimes you might be more comfortable with that. Okay, so we go back. Let me just erase my work. We go back here, and we want to find the range of f. Remember, y represents the range. To find the range of f with the Second method, we know sine is between a -1 and 1. So second method, we know sine is between -1 and 1. And we know sine x is y plus 1 divided by 2. Okay, so if you put the 1 to the other side, you get y plus 1 divided by 2, right? So I hope everybody can see from here. If you solve for sine x, you get y plus 1 divided by 2. Okay, therefore, y plus 1 divided by 2 is between -1 and 1. So if I multiply everything by 2, this becomes -2. This goes away. This becomes +2. So remember, we are working for y. Okay. So y plus 1 is -2 plus 1. Now subtract 1 from here, you get -3. And here you get 1. So that gives you the same answer. And you're done. Again, second method. Also, I'm going to give you the third method for practice. Range of f method 3. We know sine is between -1 and 1, right? So I'll make it look like this. Y is 2 sine x minus 1, right? So multiplied by 2. You get -2, 2 sine x plus 2. And then to make it look like this, subtract 1. Subtract 1 from every side. So 2 sine x minus 1 is between -3 and 1, and that's equal to y, and that's the range. I went over these methods because I wanted to show you different methods for practice. Okay, class? Obviously, you don't have to do all methods. All right. We want to find the inverse function of f of x equals 2 cosine 3x plus 2, where x is between -2/3 and -2/3 plus pi. Find the range of f and domain and range of f inverse. We're going to go through the same process. And number one, we want to find the inverse here. We're going to call f of xy. Number two, interchange x and y. This becomes x, this becomes y. And again, right here, we do have the inverse. However, we don't stop there. We're going to divide both sides by 2. If I divide this one by 2, I get x over 2, and this 2 goes away. And now, by definition of an inverse, if cosine of 3y plus 2 is x over 2, that means cosine inverse of x over 2 must be 3y plus 2. Now, if that is the case, we're going to subtract 2 from this side. So there are a couple of steps left. So cosine inverse of x over 2 minus 2 equals 3y. And y is 1/3. Let me just write it here. Y, we're going to divide by 3, is 1/3 of cosine inverse of x over 2 minus 2/3. So you're dividing this one by 3, and you're dividing this one by 3. That's the answer. We call it f inverse. So y, or f inverse of x, is 1/3 cosine inverse of x over 2 minus 2/3. I hope everybody's fine with that. All right. So we found the inverse, and it wasn't too bad. Now let's go with the domain and range. Let me erase my work. So this is the domain of f of x, which makes it the range of f inverse. So y is between those two values. Okay, begin reminding you of that. So y is between those two. That is the range of F inverse. Now, let's go to F inverse. And as we look at F inverse, it's 1/3 cosine inverse of x over 2 minus 2/3. And remember, for cosine inverse of x, domain is between -1 and 1. So that means whatever this is, it doesn't matter what you have here. Whatever this argument is, x over 2 must be between -1 and 1. If it were x over 3, the same, whatever this is. So if I multiply both sides by 2, this becomes -2, this goes away, this becomes 2. In other words, multiply both sides by 2, and you're done. This is the domain of F inverse, which is the range of F. And we're done. Okay, everybody, it's that simple. We are done. But again, let's quickly look at a second method. Here's method 2. We know cosine is between -1 and 1. If cosine is between -1 and 1, it doesn't matter what the argument is. Cosine of theta, gamma, 3x plus 2 makes no difference. It's between -1 and 1. So you want to make it look like that. You multiply. If I multiply this by 2, looks like that. So make it look like this. Multiply by 2. If I multiply by 2, this becomes 2, this becomes a -2, this becomes 2. And therefore, y is between -2 and 2. This may be maybe a tad easier. I don't know. But the bottom line is there are more than two ways, more than one way. There are sometimes 2 or 3 different ways. All right, let's look at this example where we want to find the inverse function of f of x equals 2 tan x minus 3, and x is between -π/2 and π/2. Find the range of f and the domain of range of f inverse. The same concept. And first and foremost, we start with the function, and f of x, we call it y. And again, remember, when we want to find the inverse, the reason we do it that way, because it makes it easier to deal with. Interchange x and y. This becomes x, this becomes y, and right here we have the inverse. However, we should solve for y, which means we have to move the -3 to the other side. Make it x plus 3 and divide it by 2. So tan y is x plus 3 divided by 2. By the definition of an inverse, if tan of y is x plus 3 over 2, that means tan inverse of this expression must be y, which we call it f inverse. So y is tan inverse of x plus 3 over 2. Or simply y, or f inverse of x, equals that. So pretty straightforward, everybody. So here's the domain for f of x, which makes it the range for f inverse because of what we have already discussed. So range of f inverse of x is the same thing. Y is between these two numbers. Now, to find the domain of f inverse, here's the f inverse. Remember, with the tangent, the domain has no restrictions. So x plus 3 divided by 2 is between negative infinity and infinity. Remember, tan inverse, because the domain becomes the range here. So that means x has no restriction because you can multiply by 2. Class, let me just show you. If I multiply both sides by 2, 2 times negative infinity is still negative infinity. Okay. And if I multiply, if I subtract 3, it makes no difference. This is still negative infinity. This is still infinity. And that's really the key that I want everybody to pay attention to. Okay, this one is less than. This one is less than. Same here, same here. And so this is a typo, everybody. It's all less than. We don't have equality. When it comes to um, when it comes to infinity and negative infinity, everybody, that's a concept, okay? That's not a number. So we never have equality as far as negative and positive is concerned. So let me just make sure that we see that all of this, we don't have the equality. No equality whatsoever. Okay. All right. And so second method, again, they're all, they don't have the equality. So we know tangent is between negative and positive infinity. So we want to make it look like that. How do you make it look like that? Multiply by 2. When you multiply by 2, 2 times negative infinity or 10 times negative infinity makes no difference. It's negative infinity. The same thing with the infinity. And then you add negative 3 or you subtract 3, nothing changes. So this is a second method. Okay. And I hope everybody is okay with that. Again, all of those less than or equal changes to just less than. It's a typo again, class. In other words, this one, this one, this one. That's just a typo, everybody. Find the inverse function for this case, f of x 3 cosine x plus 1, and x is between 0 and pi. And we want to find the range and range of f and domain of f inverse. So we start with this function and we change f of x to y because again, it makes it easier to deal with. Interchange x and y. Right here, we have the inverse, but we're going to solve for y, which means we're going to move the 1. And then divide by 3. Cosine y is x minus 1 over 3. And by definition of an inverse function, therefore, this means y is cosine inverse of x minus 1 over 3, which we also call it f inverse. So we found the inverse. That's the main part. We are done with that. Now we want to look at the domain and range. Domain given for f of x is 0 to pi. That means range for f inverse must be the same thing. So the range of f inverse must be the same thing. Of course, in this case, x is between 0 and pi. In this case, y is between 0 and pi. And of course, the endpoints are included in the case of sine and cosine, okay? Not in the case of the tangent. And so domain of f inverse, if you look at this one, has to be between -1 and 1, right? If we multiply by 3, this becomes -3, this goes away, this becomes 3. And if we add 1, 1 here becomes -2, 1 here, just x, 1 here becomes 4. So in other words, just so what I mentioned, so multiply this by 3, and over here you add 1. And so x is between -2 and 4, the domain of f inverse, which is the range of f. Range of f, y is between those two values. The other method is very simple. Pass y represents the range. So we know cosine is between -1 and 1. So make it look like that. How do you make it look like that? First, you multiply by 3. So if I multiply by 3, I get -3 less than or equal to 3 cosine x less than or equal to 3. Finally, I need to add a +1. So if I add 1 here, this also becomes -2. This also becomes 4. And if 3 cosine x plus 1 represents y, y must be between -2 and 4. And that's exactly what we have here. Same answer.